All right. So yes, again, thank you everyone for joining us today for the first one of these virtual ones. So hopefully it's a lot of fun. So topic today, .NET Framework today, .NET Future tomorrow. Just wanted to highlight some of the points of kind of what's out there now, the history behind these things, some of the technology, make sure that we all understand exactly what these pieces are. There's a lot of different components to .NET as a whole, and there's a lot to explore. So why does this matter? Why are we having this conversation? What's coming around the corner? Well, .NET Framework has seen a number of version bumps, 4.5, 4.6, 4.7, 4.8. Before that, it was all the other versions. And now we're at a crossroads where the .NET Framework 4.8 is going to be the last major version of .NET Framework. So .NET Framework is eventually going to lose support and reach its end of life. So what's the next step? What can you do? Well, the next kind of logical step for what's going on with the versioning is there's .NET Core. And .NET Core overlaps some of these .NET Framework versions in timeline, but the major point here is that .NET Core is the jumping off point into what's coming in the future, which is .NET 5. And we'll cover what all these things are, .NET Framework, .NET Core, .NET 5, some of their features. But the important thing to take away from this graphic is .NET Framework is at its end. And so you can stand on top of the cliff or you can jump in the water, and hopefully there's no sharks with lasers on their heads in the water, but we don't fully know that yet, and we'll know that sometime later this year.
And Mike, that's actually the perfect segue into our first poll, and that is asking our folks here, where are you guys currently right now in your .NET journey? Hopefully no one is swimming with sharks that have lasers attached to their heads. But yeah, everyone should see a poll here to answer. We'll give folks a few seconds here to go ahead and respond, just to kind of give us an idea of, where are you on the .NET precipice here?
Cue the Jeopardy music.
Oh, this is really where I was hoping the oboe solo would go. Thought it could be really lovely.
Yeah, all I have next to me is my kazoo.
You know, I'm a big fan of the Imperial March.
Classic.
Yeah. All right, so we'll go ahead and give just one more minute here. Looks like some responses are coming in. And it looks like right now in the lead, debating about upgrading or migrating versions of .NET is the big one there. So that's perfect.
Yeah, awesome.
Yeah.
Let's talk about it.
Absolutely. So I'll go ahead and close the poll here. Thank you everyone so much for those that voted. Perfect. So yeah, 55% of folks said debating about upgrading or migrating versions. 25% said wanting to learn more about .NET. 15% said thinking about starting up with a version of .NET. And then I'm imagining Chris Rim was the 5% that said .NET, what's that? Chris, this webinar is especially for you, sir. So thank you so much.
Perfect. Okay, so if you've ever been to one of my mind melds, you know that I like to do some history usually with these things. So this is a graphic that I stole from the internet. This is from a JetBrains developer. But the key points here, when we look at the history of .NET Framework especially, it's been around 18 years at this point. So this is not a new thing. .NET has been around for a long time. And .NET Core is relatively young, coming in from 2016 and kind of going until 2021-ish. There's really not going to be another version of .NET Core after 3.1. It's going to move to .NET 5 as of the end of this year. We'll talk about that more, but other important takeaway here is look at the gaps between the versions. So especially on .NET Framework, this is not a structured release cadence, right? You might have a release 1 year, you might have a release 2 years, 3 years, sometimes a release within the same year. There's no pattern to this, and some of that has to do with the fact that .NET Framework is a big thing. It's a really big framework, and Microsoft has historically had a lot of work to do when it comes to testing these things. How do they test a whole framework? And that takes a lot of time, it takes a lot of energy, and it takes a lot of effort because they're testing the whole framework all the time whenever they're making changes. They don't want to break anything in the past, and they have to make sure all the support they've had is also being carried forward. So this is a pretty big thing. And that's going to change. We're going to see a slightly different pattern moving forward into the newer versions of .NET. It's going to be a little more structured. But yeah, I'm curious, I don't know if in the comments you guys can post, has anybody actually used any of these earlier versions like Framework 1, Framework 2? I mean, these are old things. I'm curious what the experience is amongst everyone out there listening, but there's a lot of history here. So let's talk about what these pieces are. Before we get to that though, I want to cover something important. So this is kind of a surprise. Let's talk about the common language runtime. So before we ever start talking about .NET or .NET Core or .NET 5 or any of these things, this is an important one to cover because what is the CLR? And the common language runtime, the thing that you install or is installed with Windows by default. If you have Java experience, it's the same thing as a JVM. So Java Virtual Machine and a CLR, they're process virtual machines. The way that they're similar, they both have things like garbage collection, they have runtime level security, they have exception handling. Some of the differences, JVM, it was originally designed specifically for Java. It has other language support like Clojure now. The CLR has always been designed as a language neutral VM and runtime. And the JVM was designed from the beginning to be cross-platform, and the CLR was not. And that's changed now with Core CLR as we're looking at what .NET Core can run on. So what happens with your typical code? And this is something that many people don't really care too much about, but it's kind of an interesting technical discussion about how does .NET actually work. So for C# and VB, we have something called the Roslyn compiler, and the Roslyn compiler takes your code or our code that we write and compiles it into some metadata and CIL, or the Common Intermediate Language. And so this used to be called MSIL for Microsoft Intermediate Language. So what that stuff actually is, it's not machine code. It's exactly, it's an intermediate language. So it's a bunch of platform independent instructions that later will get compiled into what is actual machine code. And the metadata, if you actually inspect metadata, it basically looks like a bunch of tables. It defines types and their relationships and just a bunch of information about the code. And the intermediate language is pretty high level. So it's not platform specific, it's not assembly language, it's load some class into some place and load this value into this value. Into this variable. So it's pretty high level. So you can inspect these things. ILSpy, you can actually take your code and look at these things if you're curious what this kind of stuff looks like. So once we have these things, once we have some metadata in an intermediate language, we can use a JIT compiler in the runtime to take our code. And so JIT stands for just in time. So it just in time compiles our code into machine code that's platform specific then, depending on what you're running on. So when you start your application, the JIT compiler takes your code, compiles it, and then stores it in a likely stores it in a cache, so that if you have methods that you're calling repeatedly, those methods are already pre-compiled. So it's kind of all the time compiling code on demand. And the CLR then holds and runs that code. So for .NET, that JIT compiler now is the Ryu JIT. So if you're curious, it's RYU JIT. And you can look up kind of more information about the history behind that thing. But that's what they're using now. So what's the future look like for this? It's likely going to be some combination of JIT and ahead of time compilation. So how does JIT and AOT compare? Well, just in time compiles your kind of platform agnostic code into something that's platform specific, and ahead of time compilation is more in the vein of what a language like C compiles to actual assembly language right away. And AOT is not new to .NET. AOT has been around since the early days of .NET, and there's been lots of projects that have worked on how to improve this and make it better. So today we have things like the CoreRT project is one that's really trying to tackle more of this AOT process. The way that they do that is the CoreRT is really just a refactored .NET Core runtime, and it has services in it like garbage collection, which we really care about in our CLR, but it's executing machine code. So you're pre-compiling code, and then you're basically shoving it into an environment that has all the kind of nice services that we like to see in a managed language. So it actually uses the same compiler. It uses the Ryu JIT compiler for ahead of time compilation, and then shoves that code into the CLR. What does this buy you? So what does it matter? Well, having a JIT means that you are very platform agnostic with your code, because the runtime determines basically what the end state of your code is going to be. Ahead of time compilation has to be platform targeted, right? So now we're losing out some of our portability for speed, because ahead of time compilation can provide as much as 60% improvement in startup speed of your code. So the code will start up. It's basically a zero, work operation to get your code running. It just loads. And .NET Core is, it also has some AOT improvements. So it has what they call ready to run images that you can build with .NET Core to help improve startup times. If you really, really care about startup times and you really, really know everything about your machines that you're deploying to, you can use some of these AOT improvements to help your startup time. Other things you can look at is like the .NET Native project is also something that Microsoft supports for ahead of time compilation. So it's been around for a little while. It's not necessarily something new, but it is also going to be part of the future. Okay. Let's talk about .NET Framework. So .NET Framework is, as you saw in the history slide, it's the original .NET. It is what was built many years ago, and it's what is used today, and it's been steadily improved upon all the time. It's a Windows-only framework, really. I mean, we'll get into some of the potential portability of .NET Framework, but it's really designed and built for Windows. So WinForms, WPF applications. If you want to build web applications, you would then use ASP.NET running in Windows behind an IIS server. It ships with Windows, so .NET Framework is actually bundled with Windows, so the whole runtime comes with Windows by default. It's built on basically one giant library, the .NET Framework Class Library, or the FCL. And that's kind of the heart of the .NET framework. And it's one big thing. So it's heavy, it's monolithic in design, it's closed source. So you can actually view the source of this. Microsoft has something they call the reference source. So you can go view the reference source of the .NET framework, but you can't, it's not, there's no contribution to that project. There's no community around it. Go ahead, Lane, sorry.
I said no pull requests, no.
Yeah, no.
Add your own.
Yep. So again, it's heavy, but it's very stable. It's been around for a long time. It's been improved upon. Things have been fixed. It's been optimized. It's been modernized. It is still a valid framework today, just as much as it was years ago. All right. So let's contrast that with .NET Core.
.NET Core. Woo! What we're here for. So Core contrasts with framework in a lot of different ways, which most people probably know just by reading a couple of Microsoft articles about it. But Core, mainly at its core, is cross-platform. So you can support various platforms like Linux, Mac OS. It does have issues that .NET Framework applications don't have, in that it doesn't support some Windows-specific stuff. So like WinForms, WCF applications, those kind of things are not supported by Core. But as opposed to being a big, heavy monolith like you see in Framework, you have a much more modular set of core libraries. So as opposed to getting this gigantic framework to be able to run your application, you have various small pieces, and you can pull down what you need, and what you don't, you just leave. So one of the main advantages of Core over Framework is that if you want side-by-side versions, so if you want to have different versions running different parts of your application, you can do that. Framework, you can't, sort of, as is everything. And because of the modular architecture, I know in Mike's first slide, he had talked about the release cycles of Framework, and you can sort of see how it starts to trickle up to the Core release cycles, which are a little bit more on a steady cadence than the Framework cycles. But it's much easier and faster to deploy changes for .NET Core because it's so modular. So you can take the specific piece, you can make changes, you can push those out, as opposed to having this gigantic framework that you need to test, and you need to make sure the whole thing is running properly before you release a new version.
Hey, Lane and Mike.
Yeah.
We have a great question that I thought might be nice to interject here.
I love great questions.
Yeah, so around .NET Core, I know for several folks, maybe making the transition can be a little bit of an uphill battle, especially with the other options out there, like quick moving, adaptable competitors like Node.js, or like you mentioned, ASP.NET having 15 years of stability features. Can you talk about why someone might go with .NET Core, or the promise and excitement around .NET Core versus like a Node.js?
Sure. Well, Node.js is JavaScript, so that in of itself is already enough reason to not go to Node.js.
But for real, if you have a team of C# developers, then it's going to be much more difficult for you to convert to something like that as opposed to .NET Core.
Well, so I think, important things with .NET Core is, and Microsoft's stance in general. So .NET, it's traditionally been this very closed source, very large thing. It's monolithic, it's fast, it's enterprisey, and the world has kind of moved on from that, right? We're now in high performance, high feature, kind of web focused application development. And Microsoft has been listening to this, and they didn't want to get left behind. And Microsoft has a really great set of tooling for developing applications and debugging tools, and they really wanted to leverage all this kind of stuff into what is the future of web development with Microsoft products. So .NET Core looked at, the Microsoft team basically looked at what the state of affairs is. And we'll talk about certain things later, like web servers, but .NET Core uses a web server called Kestrel. And Kestrel is actually based on the libuv library for its under the hood working components. And that's the same thing that Node.js uses. So they really tried to get out there and look at performance metrics. You know, Node is always really high performance, and they wanted to match or exceed a lot of that performance in a lot of areas. It's, you know, .NET Core is open source, so they're really getting behind having a community-driven approach towards developing the framework. And those things all put together, you know, looking at some of the decisions they've made for how you configure and run these applications, how you develop and feedback cycles. These are all very important things that have changed in .NET Core, that have been accelerated, that have been brought into modern patterns, and coupled with all the really truly amazing development tooling that we have with things like Visual Studio. And I'm going to caveat this with, as a .NET developer, I've used both Visual Studio for Windows and I've used Visual Studio for Mac. And I cannot recommend Visual Studio for Mac as it stands right now. It's still somewhat of an early product, and we have a significant amount of issues with it, but it does work. It will, you know, it's getting better all the time, but the development experience on Visual Studio for Windows with all the way that you can debug the code is extremely rich. The way that you can write the code is extremely easy and rich, and there's a lot of extensions for making that better. And I have not yet seen, even with tooling like VS Code, I haven't seen IDEs that match that performance, especially for things like writing Node.js applications. So the development experience is better. The performance has gotten a lot better. The deployment cycles are easier. The footprints are much smaller. So really, we're starting to see some parity there. Now, it does matter what your team makeup looks like. If you're primarily all very seasoned JavaScript developers, then Node.js is a really good logical step for you, because you already know all the pieces you need to make those APIs stand up. If you're not a seasoned JavaScript developer and you're looking at what you should be getting into, then really you need to step back and look at the features that each of these things provide and kind of analyze them for what your needs are. But .NET Core runs a lot of both enterprise and non-enterprise applications in the world today, and it is fastly becoming one of the more popular frameworks for even modern web development.
Awesome.
I hope I answered the question.
Thanks so much, Mike. And just a quick reminder before we hop back in here, yeah, if you do want to follow along the presentation, I think I forgot to mention this earlier, below there are handouts attached that you can download. So yeah, feel free to download and peruse. Yeah, and I'll hand it back over to Mr. Lane. Thanks, guys.
Thanks, Nate. Should we have a poll to determine if Mike answered the question or not? We don't know how to do that. So the last thing I want to hit on Core is we have a CoreFX libraries written down here. So essentially, this is just kind of an extension of showing the modularity of Core and their approach to making Core, in that they took, so CoreFX is essentially a bunch of base class libraries that you use in .NET Core. It was actually just a fork off of the BCL, which was a base class library from .NET Framework. And they took this fork, they refactored it all to make it very modular, very lightweight, so you can, and this just is one of those things that one of the tools that helps you take down specific pieces of Core and just bring in whatever you need, where you don't have to take this gigantic package and just throw it in, so that you can have the small pieces that you want. Cool, so I think we can move on.
Well,
Unless,
I
Mike,
wanted
if you
to
have anything.
one more thing to touch about there about CoreFX and the FCL. So the framework core library, that's a big monolithic design. And like Lane said, CoreFX is a bunch of smaller pieces that you need. So as you're writing your application, you're kind of determining which parts of that CoreFX library is going to be deployed with your application. And that's all through NuGet. So you can take different pieces through NuGet, which is the kind of default package management service for Microsoft applications, and you bring those into your application. So instead of deploying, 100,000 different APIs in the FCL with your application, and you only use maybe 20 of those, you really get kind of choose your own adventure. You get to pick which pieces of what you need. And then on top of that, the nice things here is that the OS specific things, the CLR, those kind of things, that can actually be most of the package managers that exist, apt-get, homebrew, all those kind of things. Those can be downloaded directly through those package managers again. So it's pretty clear that Microsoft is really going this route where it's really involving a lot of package management to bring in all the pieces that you need and assemble your applications kind of as you go. So very nice step forward, in my opinion. ASP.NET. And I think Lane froze. So I can talk.
Yeah, he just said he lost connection here, so he'll be rejoining shortly. So.
Okay, well I'll start this off, and hopefully Lane will join us back up. So ASP.NET, why I wanted to bring this up is, again, there's all these pieces, right? .NET Framework, .NET Core, ASP.NET, and sometimes I think people assume that ASP.NET is just .NET, that is all of what we're talking about, and it's not exactly like that. So ASP, the successor to Active Server Pages, ASP.NET is the successor to Active Server Pages, and I don't know if any of you have ever worked with Active Server Pages before, but it's a nice step forward. So what is ASP.NET? Well, I know it's called the .NET Framework, but in my mind it's really a platform. And ASP.NET is a framework on top of that platform. So it's additional tooling that sits on top of the base framework, and it handles not all, but it handles the vast majority of building web applications. So that's what it's geared towards, building MVC apps or Razor Page apps or whatever kind of web technology you want to use. So it's really designed around the web component of building web applications. Important call out here is that ASP.NET Core, it can run in both CoreFX libraries and the FCL. So it's a nice choice if you have existing .NET Framework things that you run in IIS. You can also side-by-side deploy those ASP.NET Core applications there as well, and it can work just fine, no problem. Web server options for these things. So traditionally, it's just going to be IIS for ASP.NET for the .NET Framework. And for .NET Core and ASP.NET Core, you have the options of IIS, or you can use what I talked about a little bit earlier, which is the Kestrel web server. So I want to take a second here and just talk about a little bit what Kestrel is and what that means for us. So Kestrel is a ground up build of a web server implementation from Microsoft. And like I said before, it uses some of the same technologies that we see in modern web frameworks now. So it's an event loop based web server. It's designed to be a stripped down, basically as little features as possible, hyper performant web server. So it is designed around servicing a lot of requests very quickly. That's what it does best. And how does that compare with IIS, for example? Well, IIS is in many ways the opposite of that. It is a everything in the kitchen sink implementation. It has every feature, every possible thing that you would ever want inside of a web server, but it was never built around performance. Now it's performant enough. I'm sure some of you are shaking your head out there and saying at the screen that no, it's very, very performant. And I agree it has some performance, but real world testing proves that it's not really that great when you compare it against a lot of modern frameworks. And so what does that mean for us? Well, it really means that if you're going to deploy a Kestrel instance, you don't usually expose that to the world because it does not handle things the same way that an IIS instance would, and it doesn't have all the features that you might need to run an enterprise level application. So what do? Well, you proxy your Kestrel instance through something else like IIS or Nginx or Apache, whatever. And you use those proven big enterprise level technologies in front of your Kestrel instance, and that handles a lot of the things that you might need that you won't get out of Kestrel out of the box. So what are some of those things? URL rewrites are not supported with Kestrel. Request filtering. The biggest one to remember is port sharing. So what does port sharing mean? With IIS, you can run 2 applications on port 80, and they'll both be serviced on the same port. And then you use the URLs to govern which application is being accessed. Kestrel doesn't do any of that. It just runs on a port. So if you have a server with 2 Kestrel instances on it, you can't run them on the same port. So that's why you need something like IIS in front of it, or some kind of load balancer, whatever that might be. You need some way to say, okay, www.myapp1.com goes to this server on this port, and myapp2.com goes to the same server on a different port, for example. You need some way to route that traffic, and Kestrel's not going to handle that for you. The nice thing about ASP.NET, especially ASP.NET Core, is built-in DI and configuration. So these things are different between ASP.NET and ASP.NET Core. ASP.NET Core was built around dependency injection at its heart. So it has it built in, no special packages. You don't need an inject or Unity container or whatever. It's built right into the framework. The way these things are configured are also a little different. Typically in an ASP.NET framework application, you're going to have something like a web config file that configures your whole application, and that gets deployed with your application. But in modern sort of DevOps practices, we don't want to check in configurations with our code. We don't really want to have secrets exposed to the world, all that kind of stuff. And the way around that is really configuration through environment variables on running environments. So ASP.NET Core from the ground up, again, was built around supporting this. So when we deploy applications with ASP.NET Core, there's no configuration file for those things. All that comes from the environment. And so you can still have a configuration file. It's now called an app settings JSON file. And that thing is not deployed with your application so much anymore. It's really there for development purposes. So you keep it there. You can put a bunch of fake connection strings or whatever you need to get kind of your local development up and running. But then actual deployments, that thing gets ignored and everything is through environment variables. So very, very nice configuration and very, very nice DI container built into .NET Core. Welcome back, Lane.
Hey, how's it going? My Wi-Fi decided this was a perfect time to drop.
See, these things only happen with virtual stuff. Like, it would be really weird if we were doing this in person.
I just fell down.
Disappeared.
Yeah, people might have questions.
Okay, well, I took what you were going to say.
Go ahead. Continue. I'll pick up once I'm familiar with where you're at.
All right, so I'm going to briefly cover this thing. Portable class libraries. I don't know if any of you have ever heard of these things or worked with them, because somewhere someone is yelling and saying, but it's already cross-platform.
Cross-platform.
And I wouldn't say that. Portable class libraries, you have to excuse me, I don't remember when these were introduced, but the idea with portable class libraries was, number one, is .NET Framework really has a hard time with side-by-side installations and configurations. And the idea here was that we can build our code one time and really target multiple versions of the .NET Framework and things like Silverlight or Windows Phone or Xbox or sort of Windows E Microsoft ecosystem things. So when we say cross-platform, it was never Linux machines or Mac OS or whatever. It's more still Microsoft ecosystem. So being able to support multiple versions of the Microsoft ecosystem. In all honesty, it brought more pain than I think it brought anything else. It's really the problem with these things are when new platforms get released, when there's something new and you want to support those things, you have to recompile all your existing PCL libraries to support that thing. So even if the APIs are the same for those things, you still have to recompile it to target that new framework. So it's very, very much linked to all the different types of frameworks that you're trying to target. The bigger fall down of these things is the more platforms that you want to support, the smaller the API version is that you can leverage. So like in the graphic there, Framework 4.5, Silverlight, and Windows Phone, the API that you can utilize to target all three is the overlapping section in the middle that's labeled shared. So you can really only use APIs that exist within those frameworks, those targeted frameworks. So your compatibility kind of goes down as far as like what you want to use there. But let's move on.
Yeah, so as you said, some people might say PCL is, making .NET Framework cross-platform, but this is actually an implementation that .NET Core uses that is actually cross-platform. So .NET Standard, which I'm sure you've heard, I'm sure you've seen when you go to create projects in Visual Studio that you can target .NET Standard, that you can essentially what .NET Standard is one gigantic interface that has no implementation. So this is how Core can make various frameworks be compliant with the same type of library. So you have this interface, and as long as a platform can implement it, then they'll be compliant with .NET Standard. And if you ever want to target .NET Standard, you can target any platform that is supported by it. So you can see in his diagram here that there's kind of a map to the various versions of frameworks that will work with .NET Standard that are compliant. So basically, the way that this works is you have to support the highest version of standard that you for all of the platforms that you want to support. So like if you want to support .NET Core 1.0 and .NET Framework 4.6.1, then you'll have to target .NET Standard 1.4 or higher. Another thing to keep in mind is that if you're using a 4.5 or a higher .NET Framework implementation, then you are automatically going to get the .NET Standard library bundled with your app. So, Mike, I think you had something you wanted to say here.
Yeah, so it's kind of interesting. I like to geek out on kind of the technical details of these things, but Elaine said .NET Standard is one big interface, and you can actually inspect this if you look at the .NET Standard library, because you can look at it. It's either bundled with your app if you're on a lower version of .NET, so it will be bundled with your application if you're targeting, for example, .NET Framework 4.5, so the lower .NET Standard versions, or it's actually now bundled with .NET Framework 4.6 and above. So you can actually look and see what's inside of that thing, and there's no code. It's a big interface, and I talked to Microsoft engineers about how that was done, and the answer was somebody had to sit down and actually handwrite all the interface definitions for tens of thousands of API definitions, which that sounds like a interesting day for that individual. But the interesting thing here is how it actually works. So it uses a mechanism called type forwarding. So if you look into that thing, we can see type forwarding to basically define, okay, if your .NET framework installed, you go to this thing. If you're .NET Core, you go to this thing. And so there's no implementation there. It's based on what is running on the machine at that time. And that's how it keeps a really nice, truly more cross-platform standard. The other thing to remember is this is a standard that the frameworks adhere to. So basically what we're saying here is that .NET Core 2.0 is .NET Standard compliant. So we are complying with everything the .NET Standard has in it. And the .NET Standard is an additive thing. So if you're compliant with 2.0, you're compliant with 1.6, you're compliant with 1.5, you're compliant with 1.4, and so on. So you can really tailor your versions to meet the demands of what you're deploying to. Now, the other important thing to see here on this chart is the latest version of .NET Standard is 2.1, and .NET Framework has NA, and that is because the .NET Framework will never become more than 2.0 compliant. It will never be 2.1 compliant. And part of that also is we're seeing the end of life for the .NET Framework with 4.8, and that is not 2.1 compliant. So, you know, moving forward, then we're going to start losing out on features that are in the .NET Standard APIs that we can no longer use within .NET Framework. Okay, next. So let's talk about .NET 5, and it's called .NET 5 to alleviate confusion with .NET Framework 4, but really .NET 5 is .NET Core. It's just the next iteration of .NET Core. So what is .NET 5? Why does it matter? Why do we care? Well, it's going to start unifying features in the .NET Framework and features that are in .NET Core. So traditionally, .NET Core applications can't really run things like WinForms. You just can't build those things at all. Well, now with .NET 5, we're going to have that functionality. So WPF, WinForms, UWP, all those things are going to start showing up, and we can develop those things in .NET Core now. So we can start leveraging more Microsoft-specific technologies in a .NET Core application that we can treat as something that's more cross-platform. I don't think that really means you can run, you know, a WinForm on like a headless Linux box, but I'm kind of excited to see where they go with this. So again, we're going to see .NET 5 inside of .NET Standard. So .NET 5 will be whatever the next .NET Standard compliant is. So we can have still some of that cross-platform compliance there. And bigger important things here, yearly release cadence. So we're going to have .NET 5 this year, .NET 6 next year, .NET 7, .NET 8, so on, and it's going to be a biannual LTS. And if you don't know what LTS stands for, it's long-term support. So LTS is typically a term that's been reserved for open source applications, and guess what? .NET Core and .NET 5 are open source, so now we're doing LTS. LTS is the term for these things is 3 years. So what that really means is that Microsoft and the community agree to support a specific version of this. So .NET 6 is going to be the next LTS. They're going to support .NET 6 for 3 years after it's released. So this is really starting to fall in line with enterprise deployment plans. You obviously, if you're on an enterprise scale application, you want to make sure that it's going to be supported for more than just a year, and you're going to have all the latest security and bug fixes and whatever. And so you really want to start choosing LTS. This is the same way that, for example, Ubuntu server works. Ubuntu usually has, you know, latest and greatest versions that they release out all the time, and then they have an LTS version that then gets supported for 3 years. So same kind of thing. So .NET Core 3.1 was released in December 3rd, 2019, and it will end its life in December 3rd, 2022. So that was the last LTS version. And as we're talking about, .NET framework, I'm not 100% clear, but what I could find based off of Microsoft documentation is it should end its life within 5 years. So it will be supported, 4.8 will be supported as long as Windows 10 is supported. So they use as long as Windows 10 is the major version. So they're going to be still rolling on for quite a while with bug fixes and all the kind of, security patches and so on. You're going to see those things come through your Windows security updates, but there's going to be no new feature development on there, so no new major version releases. But if you're curious, Microsoft has all this kind of stuff published. It's a little bit cryptic at times, but it will be supported as long as Windows 10 is supported and updated. So that's how long the .NET framework will last. So then, other technologies that we didn't really touch on here is Xamarin, Blazor, Mono. They will switch to the CoreFX, the core-based libraries, which is really cool, especially seeing Mono. Mono traditionally, if you don't know what Mono is, Mono was a open source project to get .NET to run in a Unix environment. And it was purchased by Microsoft, and now it's actually a core component of Xamarin. So it's a smaller runtime. It uses actually some ahead of time compilation, like what we talked about earlier. And they are also, and it uses its own kind of forked off version of the libraries from the reference code. And now it's going to be switching to also the core-based libraries. So we're going to start to see new features, bug fixes, all these things trickle down across the whole landscape of sort of .NET ecosystem, which is really nice. All right, if you don't know what Blazor is, it's WebAssembly, it's .NET WebAssembly. So that's going to be the future. Oh.
Allegedly. Don't disagree. So sorry, we'll try to speed some of this up so we can make sure we get time for questions here. But so reasons you might want to switch to core. This kind of ties into the question I was asked earlier slightly. So C#8 is an important one. There are going to be a lot of features in C#8 that are just going to stop being, that are not going to be supported in framework at all. So like pattern matching enhancements and like various, I mean, there's tons of things that C#8 handles. So if you're trying to future-proof yourself, .NET 5 is essentially the next like logical version, and this next piece kind of ties into that as well. It's the future, and the longer you wait, the probably more difficult it's going to be to switch over. Possibly, they could make it easier, but it's most likely going to be harder. .NET Core has tons of performance improvements over .NET Framework. So if you're going to be doing things like if you're wanting to not tie yourself up with like input-output bound operations, then asynchronous communication is very heavily supported in .NET Core, which would be very helpful for you. The Kestrel web server that ASP.NET Core, that .NET Core runs with by default, is also built to handle asynchronous communication. And if you plan to take a cloud-first approach and deploy all your stuff to the cloud, use containers, if you want to utilize those tools, which are very awesome for developing web services, then you get first-class support from .NET Core with those things. Mike, did you have anything super exciting you wanted to add here?
Yeah, so some examples of C#8. You can get C#8 to run kind of in .NET 4.8, but it's a hack and it's not supported and it's terrible. So that's not really the future. And some of those features, outside of just syntax sugar that we like, real world examples of this is system.threading.channels is something that we've used on an application that we've built at DeveloperTown, and that's something you can't do in .NET Framework because it's a C#8 language feature. So there are new things coming out that you just won't be able to support, and we're going to try to speed this up a little bit. I know we're running really close up on time, so I'm just going to start yelling. All right. So reasons to cling to the wreckage. So haha, you can see where my heart lies, but if your team is very experienced with .NET Framework, or your team has really very little interest in learning new web technologies or whatever, it's maintenance mode. You're not really building a lot of new applications. You're maintaining large existing enterprise level software, and there's no, it's performing fine and everything is working fine. You don't have much of a reason to switch to .NET Core right now. The bulk of your software is WinForms, Windows Services, WCF, so a lot of Windows specific type of things. Again, right now you can't do any of those things in .NET Core, and so you can't really switch even if you wanted to. The big important one here is you value stability over performance. So .NET Framework is, as I said, it's been developed a long time. It's very stable. .NET Core is a ground-up rewrite of the entire framework, and it has bugs. They do happen, and they do get addressed and they do get fixed. But you have to keep in mind that when you're trying to get to the latest and greatest, it's not always the best thing in terms of stability. You might have bugs that you didn't have in your application before, and those are problems now. And if you rely on third-party libraries that are unsupported, so if your third-party library is some 15-year-old thing that does image processing or whatever, you're going to either have to find something else, or you're not really going to have an option to upgrade because you can't run framework level libraries inside of Core. All right, very quickly, performance. So let's talk performance. .NET Core is usually faster, it's smaller, it's much more asynchronous. So things like, ASP.NET Core, which is really devised around asynchronous communication, is going to be better and faster in performance, real world performance. Collections have been improved. So, what Lane was talking about with performance on previous slide, they've really optimized a lot of lower level things, and what that means is that percolates all of its performance out through everything that we use. So for the very low level, it's been sped up, and that means at a high level, it's also much faster. Okay, so performance, this is code. I wrote this code. It is not the best code, but it does work. So here's a test. It's a string test. The important thing to look at here is starts with. So we're taking a bunch of strings, picking a random one from the list, and we're seeing if it starts with AP. So this is a pretty common thing, type of stuff that we do, a lot of sort of string test kind of things. So I ran this a million times on an AMD chip. It's important because performance is a little different between AMD and Intel. But .NET Framework to .NET Core 3.1, .NET Core is about 26% faster at doing these types of operations. And a lot of that has to do, again, with collection optimization, string optimization. It is just faster. Okay. Link order by. So, maybe you're saying, well, I don't ever check the first letter of a string or the first bit of a string, but I bet you order by, because we all order by at some point. And so this is a little bit more of a meaningful test. I think they're all meaningful, but again, same type of code. The important thing here is we're generating a bunch of random numbers, and then we're just ordering them by the number and then projecting that to a list so that we resolve it. So this is 10,000 integers sorted 1,000 times. Again, we're seeing somewhere between 24 and 25% faster doing this link order by operation. So, and smaller memory footprint. So performance is there, it's real. And I encourage you to do your own tests and see kind of how much this performs. Now, you might be saying, okay, well, I don't ever order, a million things 1,000 times. Well, that's true. But keep in mind that, I'm doing these high load operations this way so that I can get everything to respond back in millisecond timing rather than nanosecond. And you say, well, that's, just marginally better. But you have to take into account the fact that most every operation has been optimized this way. So over the course of your entire application chain, you will see real world improvement. Now, is this the difference between my API responds in 1 minute and my API responds in 100 milliseconds? No, it's not that type of performance. But if you are really trying to optimize and really work against high scale, high performance environments, you're going to see actual benefit with these things. Okay, so we have just a few more slides and then we'll be done. So
yeah, so this is kind of gonna give you like a brief overview of strategies that you can utilize to at least begin migrating. So the first thing I would say you need to do is you need to have a test suite. So if you don't have any tests in your application and then you try to take this big application, I mean, maybe even not that big of an application, and you try to move it all over to target a different platform with totally different, well, not totally different, but sometimes different syntax and different requirements, then you're going to run into problems. So you're going to run into all kinds of runtime exceptions, just compiler exceptions that are going to make it fail for you. So recommended that you have tests. If you don't have them, you should write them so that you can test your application again after you have ported everything and make sure that you're still operating the same way that you think you are. We're mentioning an all at once just because that approach is feasible. So you can do an all at once approach. One of the complications that you can run into with this is that you may have a team dedicated to writing to porting your application to .NET Core. And if you have a team that is also adding features to your .NET Framework application while you're trying to port, you can run into issues with synchronization and trying to like migrate features that aren't done and things like that. So .NET Standard first. So we would essentially recommend that you probably have large swaths of like business logic and stuff that's almost unchanged. So you can take all that stuff, you can port it to .NET Standard, make it .NET Standard compliant, which makes it a lot less easy. You have a lot smaller footprint on the things you need to change to be able to get into .NET Core. And then the Strangler Fig, which is a pattern that is, I believe, coined by Martin Fowler, but it was about basically a type of tree that it has these like plants that come down from the branches, and they eventually form their own trees and surround the tree that they had spawned off of, the parent, and then it eventually kills and crushes the parent. So the Strangler Fig is essentially an approach to changing over like an API in that kind of manner. So you have a facade API where you essentially pass through, so you're targeting .NET Core, you're potentially just forwarding requests to the old API, and all of your new development can happen in the facade API. This is essentially the future. And then you have this old API where when somebody needs to touch something or change something or, replace a feature, then they can, instead of doing that, they can remove it and add it to the new API. So eventually you're building around this API and eventually it will die off from being ported over to the new API. Go ahead, Mike.
yeah, and so this facade API kind of thing, we've actually used this with success on number of projects to kind of whittle down on some of the old stuff and keep it running and have kind of side-by-side development with those things. So again, the problem when you have one team that's building something new and one team that's building something old is how do you keep those two teams in sync? And this way, because our facade API essentially passes through a lot of traffic, it's always in sync with the old stuff. And then as needed, you start to bring that old stuff into the new API, and that slowly starts to take over. So that's been a proven approach that works pretty well. And it doesn't just apply to APIs. You can use Strangler Fig with other applications too. If you have some console workers or something, you can kind of start to break out old pieces and surround them with new logic and new framework, and eventually it will hopefully kill off some of that old stuff. All right.
So some tools that you can try and utilize to make this maybe a little easier for you is .NET Try-Convert. So this is a tool that is built, so first off, it's not supported by Microsoft in any official way. It's a tool that was built by some of the .NET team members just to make this transition easier for some applications. And sometimes it can give you a jump start to porting your application over to .NET Core to make a .NET Framework application compliant. You can run into issues with this. So like there are some things that are explicitly not supported by this tool. And so if you have these things in your application and then you run this tool and then you try to run your application targeting a new platform, it's going to fail. So if you have things like complex custom builds, if you have APIs that you're using that are not compatible with Core, those things, this does not fix for you. So you need to fix them yourself. That's why, so because this can possibly fail and then you can be left with an unusable thing, they do strongly recommend that you use this if your project's in source control. So the API, or actually I'll start with the compatibility pack. So the compatibility pack is basically a NuGet package that Microsoft provides that has tons of APIs that .NET Framework or .NET Core does not have. So if you want to do stuff like interact with the registry, like Windows-specific things, Windows-specific APIs, then you can find those things oftentimes in the compatibility pack. One concern you can have with that is that if you're switching to Core because you want to target additional platforms like Linux and Mac OS, then you're going to be utilizing APIs that are Windows specific and are going to throw platform not supported exceptions inside of whatever platform you're actually trying to target. So they do recommend using the API analyzer if you're going to do that. So the API analyzer is basically you specify what you want to target, and it will tell you via warnings that you're going to throw platform not supported exceptions. It will essentially tell you what platforms are not supported by which API you're using. So it'll say like, hey, this is not going to be supported by Mac OS or Linux. So when you hit this kind of exception, you can do a few things. So you can either get rid of the code entirely. So if you maybe aren't going to support that feature in your core implementation of the application, you can just get rid of it. You can obviously migrate it, so you can change it and make it into something that is compatible with whatever platforms you're trying to target. Or you can, and I don't typically recommend this, but it might be the right solution for you, is you can add compiler directives to tell it, hey, only compile this code if we are on the target platform, like when it's actually going to work on. Again, that's not always recommended, but these are always, certain circumstances everybody has differently. So, oh, okay. Go ahead, Mike.
Okay, last slide, I promise. Pitfalls, these are important, but I'll kind of fly through these. Entity framework is different between .NET Framework and .NET Core. It can be oftentimes a lot different, which means you'll have some issues migrating. It has some Entity Framework Core on some of the older versions had like real proper bugs in it that were also caused a lot of headache for me personally. So there are issues kind of working out with Entity Framework Core. For example, on model creating can live in models, in your entity models, in Entity Framework for .NET Framework, and that doesn't exist in Entity Framework Core, and so now you have to migrate all that stuff to your DB context. And so if you have 400 entities, that obviously starts to become a bit of a problem. Again, the bugs. So there are bugs that can happen with .NET Core. Runtime bugs are usually the biggest problem with migrations. Is you fix all the compiler stuff, you're like, hooray, it's .NET Core now, everything's perfect. And then you hit run and somebody hits your endpoint and it's like, oh no, I don't know how to code anymore. And
runtime exceptions.
And it falls down. So again, having a lot of tests is going to help with this kind of stuff to help try to fix some of the runtime issues that might happen. But again, that's really where sort of the creepy crawlies are, is in these runtime bugs that just kind of pop up all of a sudden, and especially with Entity Framework. Entity Framework Core no longer supports, not at least out of the box, it doesn't support resolution on the web server. You have to enable that. Which is a good thing, because I think oftentimes people don't know that their code is executing on the web server and not the SQL server. And now if that happens, it just exceptions. So it tells you, hey, I don't know what to do with this instruction, and so I am now falling down. And that's bad. And last time, mixing .NET Core, .NET Framework, and .NET Standard assemblies can be painful if you are not careful. Now, I know I said in the past that this is really the point of .NET Standard, is to be able to target .NET Framework and .NET Core, and it is. And if you do everything sort of on the rails, you're 100% okay. If you start to do things, personal message here, like build a plugin system and you're using assembly.load, and you're mixing these technologies, it gets a little bit weird because of the way that .NET Standard and .NET Core treat NuGet packages, and the way that .NET Framework treats NuGet packages are different, and so you might not be able to actually load a library that you thought was going to be perfectly fine. So again, things to consider if you're doing a lot of sort of out of the box crazy, outside of the box crazy dynamic loading of stuff, you might have a lot of issues with compatibility with these things. And I have lots of these stories, so you can hit me up after the presentation. We can talk all about all kinds of good and bad things. So, all right, yeah, really, just should you upgrade? It's up to you, but I think it's awesome. As a developer, I think it's been a great new set of tools for me to utilize and use, and hopefully it will be for you too.
Awesome. Well, thank you so much, guys. Yeah, there were a few questions that came in. And Mike, actually, you just sort of alluded to one of them. And that was, does DeveloperTown have any NuGet libraries that help teams accelerate the early phases of starting a new project?
That's a very good question. So are there libraries? So let me interpret that question two ways. Are there libraries that exist in the wild that we use for typical startup? Yes, in some, it depends on what application you're trying to build, but there are typical NuGet packages that we like to use. For example, for APIs, we always use Swagger, and Swashbuckle is a fantastic library that helps to bring in Swagger and Swagger UI. Things like AutoMapper. AutoMapper is not .NET Core specific, but we use those things all the time. And really, I mean, there's a lot of libraries out there. Now, we have been in the past and continue to do so, build libraries that we use to help startup projects, and we will be deploying those to a NuGet repository so that those are available for other teams to help utilize, and they give you things like one-line project startup or project templates that let you just start up a whole API the same way that we would typically start up an API. So that's a new project, DeveloperTown API, and then you hit start and you have Swagger integration and some endpoints and typical auth stuff and that kind of thing. So those are coming. Honestly, the only reason those don't exist right now is because NuGet decided to mess up our NuGet corporate account, and I'm still working with them to resolve that, but those will be coming soon. So, yep.
Awesome. Got another great question for you here. Someone would like to know your thoughts on encryption, specifically using Microsoft ASP.NET Core data protection. Is it reliable, secure, efficient, or any issues when deploying to multiple servers?
ASP.NET Core data encryption. Let's see. I don't know that I have a good answer to that right now. Encryption as a whole, Microsoft has been pretty good at, and the other thing to note is they've done a lot of optimizations for encryption based in .NET Core. So .NET Core, for encryption purposes, every kind of encryption algorithm has been sped up some insane amount. So the performance of the encryption is really good. Is it secure? Well, encryption is only as secure as what type of encryption model you're using. To be honest, I'm not that familiar with what exactly that technology is.
Yeah, I'm not familiar with that library.
Don't know that I have a good answer to that one. But is it secure? I mean, it's definitely going to be faster. Is it secure? I don't have a good answer. I mean, it should be secure, but
Should be.
Yeah, I don't have the knowledge there to speak at length on that one.
Will .NET Core support New Relic?
Oh, New Relic, huh? Okay. I'm sure New Relic will support .NET Core. I don't know if it does now or not. We don't actually use New Relic, so we use alternative technologies for APM monitoring and server monitoring. Typically, we use Datadog. It's, in my opinion, better and cheaper than New Relic, but what I'm seeing in terms of other APM solutions like Stackify, they are all moving towards supporting .NET Core, so those technologies should be coming, and New Relic should absolutely be supporting .NET Core as well in the future.
All right, got 2 more here for you. We currently are using ASP.NET, and trying to unit test things is difficult. Finding we've got a dependency on a concrete implementation that's also sealed. How or does .NET Core make the unit testing or testable world easier?
Okay. So let's talk about unit testing in .NET Core. So we utilize XUnit tests. XUnit, you have other options like NUnit and MS test, but we use XUnit tests for all our unit testing. It's developed by Microsoft people. Sorry, someone I think my son came into my room. Virtual stuff, right? Anyways, so we use XUnit. XUnit is developed by Microsoft people. It has some niceties that you don't have to do test startup and tear down, those kind of things. There's a lot of, I mean, unit testing, it's not drastically changed between .NET Core and .NET Framework. So it's not, you know, some completely new way of testing. It's much of the same kind of world. If you have a hard problem, if you have something, for example, where you rely on a lot of logic inside of another API and you're trying to do integration tests against that thing, there's no really easy way to say, okay, well, unless you just completely fake it, there's no easy way to test that logic somewhere else. There's in-memory databases, which make testing a lot easier. Those have their own set of limitations. So in-memory databases don't support a lot of typical raw SQL things. So you can't just, you know, execute drop table against an in-memory database. Those kind of things don't work at all. So if you have a lot of more like hand-tuned raw SQL queries, you can't do those things with an in-memory database. But for general CRUD operations, they make things a lot faster, a lot smaller, and they're good things to use. But you know, testing limitations as far as what the framework does and how it treats sealed or other types of access modifiers on your classes, .NET Core doesn't change anything in that sense. So you might still see some of the complications that you have with an ASP.NET project and an ASP.NET Core project when it comes to testing. So yeah, I don't know that there's been drastic improvements to make things way different, but some of those problems will still exist and maybe some won't, but I hope that answers the question. I don't know of a way to, you know, radically alter the way you unit test with .NET Core versus .NET Framework.
My research assistant, also I guess technically the head of development at DeveloperTown, Jason Vasquez, was sure to let me know that New Relic does have a .NET agent that offers compatibility for .NET Core and the .NET Framework.
Okay.
That works. And he actually had our final question for today. And that does .NET Core improve order by DoorDash? I told him that I thought it might have just been an Uber Eats or Grubhub only.
Yeah,
but
I think there's a DoorDash plugin if you want to use that.
I don't know if DoorDash uses .NET Core or not, so maybe they're not that much improved. Maybe they're a Node.js shop, and then like, who knows where your food's gonna go?
Yeah.
Oh, too good. All right. Well, I think that wraps it up here for us today. Apologies for going a bit over. I think our moderator was quite verbose in the beginning and got us off to a delayed start, so apologies there. Yeah, just as a reminder, we are recording this session and we will provide a link to the video after for all of our attendees. So Mike and Lane, thank you guys so much. Yeah, attendees, thanks so much for joining. You should get a follow-up email with a link to the recording. And bonus, we are also going to be offering just an opportunity to spend a few minutes chatting with a .NET expert at DeveloperTown. You'll be able to take advantage of that offer via email that we send after. So thank you guys so much. Appreciate it. Any final words? This would be a great time for your oboe finale if you've got it around, Lane.
I don't. It's actually stowed away right now, so sorry. I know everyone was looking forward to it.
Perfect.
Yeah, thank you everyone for sticking around and listening to us ramble on about .NET. And I hope this helped some of you out there. I hope it was meaningful.
Yeah, and then feel free to reach out if you have additional questions.
Perfect. All right. Well, thank you everyone so much, and have a wonderful rest of your day.